So today I am going to discuss about second chapter of the electrostatics, that is current and electricity. And in this chapter, that is in electricity, I will discuss first some simple definitions, and then we will derive different formulas which are very important, and the formula will be followed by their concepts. So in electricity, the first thing that comes in mind, that is current. So it is well known. Let us suppose we have a conductor, and the area of this portion, that is circular area, is A, and I have put a barrier, or let's say I am standing at this point P, and I am calculating the time and the charge that flow in some time limit. So let at t is equals to 0, the charge, that is q, that has passed from this point, this cross section, is 0, and initially time is 0 and charge is 0, and when t is equals to t, charge that has flown is equals to, let us say, q. So by the definition of current, it is said that current is defined as the rate of flow of charge, that is current is equals to rate of flow of charge. This means if we are standing at some location, what is the total amount of the charge that has passed through it in the time in which we are calculating. So here I am calculating time for time t, and charge that has passed in q. So I will be q upon t. So this is the formula, and if I consider about the unit of charge is coulomb, that is C. For time it is second. So unit of current that I will get from here is coulomb per second, and it is known as ampere, represented by A. It is ampere. So here you can easily find the dimension formula for I, because you simply put first the dimension of the charge q, and then dimension of time, that is t. When you will solve it, you will find the dimension of I, and most probably it is, I think, A, which is generally given in the dimension sheet, or charge is the fundamental quantity. And next, so let us suppose in the same situation, if I have done it in some time dt, not in time t. So in that place I have time dt, and the charge that has passed is dq. So in that case I will be dq over dt. This is also the formula. So if I will solve this equation further, then I can see that dq is equals to I dt. If I need to find the total charge that has passed through in some time limit, so then for calculating the total charge, I simply need to integrate on both sides. So this is charge dq. Simply I am assuming that initial charge is 0 and final charge is q, and time at time t, initially time is 0 and final time is t. So it will give total charge that has flown in time t is q equals to I t. So this is the formula, but here I have supposed that initial charge is initial charge is 0 and total charge that has passed and time t is q. Then I have got total charge IT. This formula is frequently used. So let us try to solve a question on the basis of this formula. So just change it. Okay, so let q is equals to t plus 2t square plus 3t q. So this is given that we are given charge as a function of time, and I am asked about the current. So I is equals to dq over dt. This is the formula which I have told you. Then simply differentiated t plus 2t square plus 3t cube. When you will differentiate it, then the differentiation of t will be 1 and the differentiation of t square will be 2t, and 2 is already in multiplication of it, then it will become 4t and this will become 9t square. So what I have done here is simply the formula which I have used for differentiation is, if I differentiate x to the power n with respect to x, then I will get n x to the power n minus 1. This is the formula which I have used here. So it is quite simple. By using this formula, that I will get I equals to 1 plus 4t plus 9t square. But let us suppose that if I am asked about the current at time 0, so in that condition I will simply put t equals to 0 here. Then what I will get is 1, because 4 into 0 is 0, 9 into 0 is 0. Then I will only left with 1. And if you are asked for current at any time, some other time, let us say 1, 2 or 3 other second, then you can simply calculate it. Current is in ampere, and depend on the unit which I am using for charge in coulomb. So you must know what is the unit of charge here in, whether it is coulomb or millicoulomb, then you have to change accordingly to that. So next question, come to the next concept. Let as I have said, here is conductor, and I am calculating the total amount of the charge that has flown through this lane and time t. So by using charge and time, I can calculate current, that is q upon t. But if I say, okay, my charge is flowing, so who is the responsible for the flow of the charge? That is carrier of the charge. So let us say, if I assume that this is the conductor, so it is well known to you that if we have a conductor, then the charge will flow through it. So charge is flow because of positive charge, that is positive charge. If you imagine whether it is proton or alpha particle or any positive ion, negative, that is electron. It may be alpha particle or proton or maybe any other thing, like just Na positive. Here I can put into Cl negative and negative charge carrier. So what is being going here is, when the current is flowing, so let us say current is flowing in this direction, then the current will flow always in the direction of positive charge. So it is the concept you must remember that current always flows in direction of positive charge and opposite to negative charge. So this means that in the conductor given here is current is flowing in this direction, then it is in positive charge will move in this direction and negative charge will move in this direction. So you can say that electron movement and current flow are both opposite to each other. So I hope it is clear to you. So let us come to next thing. As I have already told that in the conductor current is flow because of charge carrier. So let us go. I have given a conductor and what I am going to do here is I am just applying potential difference, and the point which you should remember is that in the conductor current will not flow until you do not apply electric field or you do not connect it with the potential source or any battery. So let us say this is a conductor, this is conductor and this is battery of potential voltage V, or you may remember it as a cell. So charge will flow in this direction. So it is known to you that in this conductor the number of charge particle will be more and more, or you can say there are a number of charge particles. So let us consider there are n number of charge particles or charge carrier. So if I do not apply the electric field or electric potential to the conductor, then the total current in the conductor is 0. So let us say this is 1, this is another 1, and this is another. These are the charge particles. This is moving in this direction and in this direction. At randomly they are moving. So what is going to do here is their net effect is 0 if I do not apply this voltage or potential. So initially they are at in random motion, and when I apply this voltage V, then the direction will get aligned. So let me make the figure again. Just leave this here. It is without any potential source, and if I have some potential source, then all charge particle will move in the direction of the electric field or opposite in the electric field. So I imagine here that they are all moving in the direction of current flow, charge carriers. So what I am going to do here is, as it is clear that there are n number of charge carriers. So for first charge carrier, V is equals to U plus A T. We know this equation, first equation of motion. So if I talk about for the first charge carrier, here is potential V, electric field that is applied due to this potential is E, and T is taken just simple T. So for the first charge particle, if what can I say? Let us say m is the mass of the charge particle, E is the charge, let us say these are electrons. So the total force acting on the electron, you can find it very easily. That is F is equals to ma equals to E into E, because total force is given, force as we have already studied is given by Q into E, and Q is E, which is E, and electric field is given by E. So force is E. So I can calculate A, that is E capital E over M. This is the A. So for the first particle, this is U1 plus A. Just simply put the value of A, E into E over M into T. For the second, this is U2 plus E over M into T. Let us say for this time is T1, for this time is T2. But acceleration for all the particles, for all the charge particles, charge carrier will be same, because mass is same and the charge is also same. Electric field that is applied is also same for all. Then acceleration will definitely will be same for all. And similarly, if I write it for n particle, this is Un plus E over M into T n. So what I am going to do here is I am just simply adding all these equations. So when I will add all these equations, so these are the equations here, I simply add U1 plus, so equations which I am adding here is these ones, not the upper one. U1, U2 plus Un plus E over M, T1, T2 up to Tn. So I hope that this is clear to you. I am rubbing it. You can note it by pausing the video. So I rub it simply. So next thing what I will do here is I just simply divide the whole equation by, what I am going to do here is I am taking the average. Why I am taking average? Because there are n number of charge particles, and for every charge particle we cannot talk about its motion. So when there are number of charge particles, we talk about the average of the particles. I hope you have studied it in thermodynamics and physics. If you have not studied, then no problem. So this equation now I am putting it as V, D, and this value U1 plus U2 plus Un up to n is equals to 0. This will be 0 because it is for the initial velocity. U1 is the initial velocity for first particle, U2 for second particle, and Un for the nth particle. When you will take average, it will be 0. The reason is that when the electric field source or voltage or battery is not attached to the conductor, then there was no current in the conductor. When there was no current, this means that the motion of the conductor particles was total 0. So it is 0, and next this quantity T1 plus T2 plus Tn divided by n, so it is simply written as a tau. So what is the means of the equation that I have got in the final? So the mean of the equation that I have got in the final is that here the velocity Vt, which I have wrote here, means the drift velocity. So this velocity is drift velocity, and tau is the relaxation time. So the next thing is, what is the definition of drift velocity and what is the definition of relaxation time. So when we talk about the drift velocity, so let us write it here. It is average velocity of charge carriers by which these drift towards the positive terminal of the battery. I have wrote battery, you can write potential source or whatever you are using. So it is what is written here is average velocity. I have taken the average of the all velocity of the each particles. And what is relaxation time? So as you have studied, so let us suppose again here this is the charge particle and this is another charge particle. If they will collide, then there will be some time between them before the for which they will not be collide. Let us say when the separation between them is L and T is the time in which they collide. So this time T in which they are free, they are relaxed, they are not colliding with each other. I am calculating all the times for every particle and taking the average. This is the relaxation time. So I hope it is clear to you the definition of the relaxation time. You can simply write it in your own words. So the topic which I have told you here is drift velocity. So next I am going to tell you about mobility. So again it is represented by mu. Simple definition is Vd over E. So it is defined as the drift velocity per unit electric field. You can write it simply drift velocity per unit electric field. So if I put the value of Vd, so what I will get, Vd is equals to E over m into my tau. When I will put it here is I will get E over m into my tau, and here is tau E. When I will solve it, I will get E tau over m, and I can write it as E over m into tau. So this value E over m, this is called a specific charge. Charge over mass ratio is known as specific charge. So what you need to do is, so let us say if you are given that you know that the charge particle is electron, you know the charge of the electron, you know the mass, you need to only know the relaxation time, and then you can easily calculate the drift velocity. So one thing what I forgot to tell you is in that formula, in this formula, what I have wrote is here is it is a simply formula. If I take the vector it in vector form, so Et vector is equals to minus E tau over m into E vector. So it is clear here. So first question is how you got this minus sign. Minus sign is because of is the charge of electron which I am using here. Charge of electron is minus, that is why I am getting negative sign. And is the vector quantity tau, time is scalar, electric charge is scalar, mass is scalar, these all things are scalar, and this is vector velocity is vector quantity. So Vd equals to minus E tau over m into E dash. So the next thing which I should tell you that you see here, you are seeing here in observing that Vd is equals to negative of E vector. If I assume that this quantity in bracket is 1, just for sake of simplicity, so what you can see that if electric field is in this direction, then the motion of the electric charge will be in this direction. That is, if electric field is going in right direction, then the drift velocity will be in left direction. So I hope it is clear to you. The drift velocity and electric field both are opposite to each other just because of negative sign. And remember that I am assuming here that electrons are moving. I am not taking account of any other charge. In place of electrons, so you may have some solution like in chemistry. Let us say it has Na positive and Cl negative. What will be the case? So this is a question for you. You need to solve it. Just try it yourself. So next thing is I have studied about Vd is equals to Ve over m into tau, and the mu is equals to E over m into tau. So if I want to find the relation between Vd and mu, so can we do that? Relation between Vd and mu. So for doing that, what I am going to do simply here is just simply divide Vd by mu. If you will simply divide it, mu E tau over m into E divided by E m into tau. So this value on upper side and lower side both will be cancelled, and I will be left only with E. Then finally I will get mu into E. So this is the relation between these two quantities. So for next things I will discuss those in next video. Thanks for watching.